So hello guys and welcome back once again. So guys, today we are back with some very good questions once again from the Allen SRG booster test series papers. So we are continuing the paper from which I did 3 questions in my last video. So if you want to refer to them, you can go and watch the last video. It is just before, like, just the previous one posted before this. Okay. So guys, this is the first question we are trying today. So what I'm doing is I am not waiting much. I will try to rapid fire, or maybe I will wait for a 5 or 6 seconds and then I will start off solving. You can try your hands out on this question as well. Okay. So guys, starting off, first thing is if the function satisfies this particular equation and f of 1 is 1 and f triple dash 1 is given to be 8. Interesting. So f of 1 is given to be 1 and f triple dash 1 is given to be 8. Okay. So basically this is our equation given f of x square into f double dash x is given to be f dash x into f dash of your x square. Okay. Now let's do one thing guys. I am putting x equal to 1 in this particular equation. Okay. So this will become f of 1 f double dash 1 equals f dash 1 into your f dash 1. Now this became f dash 1 obviously whole square. So I can write this as your f dash 1 whole square. And for this particular side, this is f of 1 into f double dash 1, right? Now f of 1 is 1. So let's track it off as 1. So f double dash 1, this becomes f dash 1 whole square. Okay. Okay. So guys, let's do one thing. What I am doing is I am taking f dash 1 to be a and your f double dash 1 to be b. Okay, so from this we get b is the equal to a square. Okay, now guys, I will obviously explain why we did this. You will understand a bit later. So what are we doing is, this question is good. This is a good question because this is not very normal to what we get. Okay, generally in these type of equations what we do is we get some relation or something and it directly comes out into a differential equation or something like that, but this is a bit tricky and that is why this question is good. So what I'm doing is I am taking this particular equation, and this might seem a little bit absurd, but we are going to differentiate this. Okay, so this will be f of x square into f double dash, sorry, not double dash, triple dash x. I differentiated this one first. After this will be plus of f double dash x into 2x times f dash x square equals to f dash x into 2x times f double dash x square plus f dash x square into f double dash x. Okay. So now what I am doing is I am again putting x equal to 1 in this equation. Now see what happens. When you put x equal to 1 in this equation, this will become f of, let's put the values, okay, one by one. F of 1, so it is 1, I'm not considering. F triple dash 1, so 8. Plus of f double dash x. I mean, it will be f double dash 1, which is b. Into 2 into 1 means 2. F dash 1 again will be a. Is equal to f dash 1, which is a. Into 2 into f double dash 1 will be again b. Plus of f dash 1 will be a and f double dash 1 will be b. So this and this get completely cancelled, and from here we get ab equal to 8. Okay, so what happens is you now have two definite equations in two variables and you can use these to solve and find out whatever you need. So basically let's quickly finish it off. So b is equal to a square, right? So let's do one thing. I am substituting a as equal to 8 by b. So this becomes, if we substitute 64, I guess, yeah, 64 by b square. So b cube is 64 means b is 4. So and if b is 4, a is 2. Which means question is actually done, because if you see our options once, I'm sorry, if you see our options here, you will notice that f dash 1 and f double dash 1 have been asked. So you have been asked the values of a and b. So I guess f dash 1 was a, right? And a has come out to be 2, so option number a. And we have also been asked f double dash 1, which is b. So b has come out to be 4, which is option number b. So correct answers are a and b. Okay. Like now one question can come to your mind, like why we need to differentiate this. So basically differentiating this has like, how will you get that idea? Okay, that is the basic question here. So first thing is, you will get an idea because b is equal to a square. You have one equation for two variables, so you have to target in finding out another equation. First thing. Second thing, in the options everywhere one is mentioned inside, or inside the parameter, or rather in place of x. So you will always target whatever you do. I will put x equal to 1 because I already know two standard values for it. Third thing, when you put, like when you look into this particular equation, you will find out that when, like, we already found one relation, right? Now differentiating this, the purpose of differentiating this is because you have single differentials as well as no differential. No differential meaning it is your f dash 0. Okay, like normal function I can treat it as f dash 0. I am just telling it something like that. So when you differentiate this, you will get f dash x and f double dash x. Actually, this was the thinking I had in my mind, that if I can differentiate this, definitely there will be terms of f dash x and f double dash x, and that is what we actually need. And if triple dash x comes also, there is no problem because we already have the value of triple dash x with us, right? So that is the, like, these small things will help you to target to where we want to reach. Okay, this was a good question, really good question. Anyways, so guys, let's proceed on to the next problem. Okay, so here is the next question, guys, and this question is by far the best problem I have seen in a few of maybe even the pre-score papers. Okay, this question is a very good question, so please try it out. Like, I will tell you some of the topics from which these people have given questions in this paper. Like, see, I didn't get all the questions because most of them are actually either in your included in your PYQs or you have already done it somewhere. Okay, like there was one question on straight lines, reflection of straight lines. There was one question. Complex numbers I have already done. There was a very simple question on roots of unity. There was a very simple question on like geometry of complex numbers. Really simple questions. Okay, like you, if you want to rate them, I will rate these questions maybe a 10 out of 10. I will rate these questions 4.5 or 6 only. Nothing above that. But like very easy questions. Okay, so I didn't feel like including them. And this question I have already done. Okay, you also had one question on your locus. You will see there are some, like, I will write maybe some questions are there, like 2 by OP is equal to 1 by OA plus 1 by OB. This is a very common question in straight lines actually. I hope every one of you have seen this or done this somewhere. There is an explicit example of this present in your, like, I hope everybody of you do RD Sharma, right? RD Sharma for your boards. If you see RD Sharma for your boards, there is one explicit example of this particular problem in your boards RD Sharma. Like, this is really easy, okay? So I didn't feel like including that. And there were a few questions also which are very inspired, like I guess ditto copied from your JEE Advanced PYQ. There was a very famous question in 2016 which had a composition of functions. It was a question on differentiation, pure differentiation, no integration as well, but it was a question on composition of functions. Okay, I guess there was a h of something like this, h of g of x or something like that. They had given three functions. That question you can see it in your PYQ, so I didn't feel like including that also. Okay, this is like overview of the paper. You know, actually generally the paper was easy. If you like the hard questions, if you actually exclude and you do the rest, you can easily score good marks in this paper. This paper is nothing of like, really not something that you can't do at all. Okay, anyways guys, that was an overview of the paper. I gave it because many people are actually asking me for the papers. Okay, so I would like to tell you that I can maybe provide you the pre-score papers. I'm getting them from somewhere, but this paper I can't provide because it is password protected. Okay, so it is very difficult for me actually to give you this paper. So I hope you will abide by that. I will try to bring in as many questions, and maybe if you want, I will bring in all the questions from the next video. Maybe that would be better. Okay. Anyways, guys, please try this question out once. This one is a really good question. Okay. A very, very good question on complex numbers. So please try this out. I will wait for a few seconds and then start on solving. Okay. So guys, first thing is they are saying that all these fractional expressions, obviously it is complex. Okay. Like, wait. One thing about this question is that you might not figure out, okay, I have already said that this is a complex numbers question, right? If I hadn't said this is a complex numbers question, then only the presence of 2i can't tell you this is a complex numbers question, okay? There can be a probability like, obviously, when I am not solving it, I is given as 1, 2, 3, 4, 5, 6, 7, 8. So many people, what they will do will, they will try to approach this geometrically, but we won't do that, okay? Whenever you see such problems, because you have learned, see, if you hadn't learned complex numbers, this can be done without complex numbers also, but if you didn't learn your complex numbers properly, then what is the use of that, right? These questions are to be done with complex numbers. This can be done with geometry, okay? That is something like I have to go back to class 10th 9th level, but with constructions and all, but that is not the scope of your syllabus. So we will do this purely using complex numbers. So guys, first thing is, if we see, these are the vertices of a regular octagon. So if I join the vertices with a not straight line, obviously, if I join the vertices, try to locate the locus of the vertices, obviously they will lie on a circle, right? So if I try to represent all the vertices of the polygon with a complex number zk, such that this zk is equal to r into e power I theta k, where theta k will obviously be, if you can't guess this right now, then take like pause the video right now, take a few seconds time and think what this can be, okay? And thereafter only play the video. If you can't figure this out, you are really in bad conditions. Theta k will be 2k minus 1 times pi by 8 for k equals to 1, 2, 3, 4 up till 8. This is nothing to do with complex numbers. This is everything that you have learned in your class 10th boards, okay? Polygon internal angles, nothing else. So the vertices will obviously lie on a circle. And what will be the equation of that circle? Mod z is equal to r. A circle with center at origin such that the circle has a radius r. Okay. Now real challenge is how do we express these in terms of complex numbers. So for that, first thing is like any person who doesn't even have brains, he will do the first thing, he will compare zk with a general fractional term given ak minus 2i, right? Anybody will do this. That is actually the first thing you need to do, okay? Don't take it comically otherwise. So this will be ak minus 2i is equal to 1 by zk. Now 1 by zk I can write it as 1 by r e power minus I theta k. So ak is actually 2 times I plus 1 by r times of e power minus I theta k. Okay. This is the first take. Now one thing is that you can understand, right? Because 1 by ak minus 2i, you can infer this thing, I guess, very, very, like, no doubt should be there about this, that ak has to be real. Okay. AK has to be perfectly real because it is a vertex of a regular octagon. Now listen to one thing. We are converting this to complex for our necessity. Okay. But like obviously you can represent the circular octagon in a complex plane. But when we talk about the vertices should be real. Rather, I should not say vertices should be real because vertices are located on the complex plane, right? Rather than saying vertices should be real, I will say AK should be real. AK has to be real, okay? There is no doubt to this. So if AK has to be real, then you have to take your imaginary part of AK as 0. Right? Very obviously. So here actually there will be a very famous entry of your Euler's form. So AK is 2i plus 1 by r e power minus I theta k. That was what we found. So I can write this in accordance with your Euler's form 2i plus 1 by r times cos of minus theta k, which is cos theta k, plus of I sine minus theta k, which is cos I, like minus I sine theta k. Actually, you should remember this form. Anyways, I told you. So this is 2i plus of 1 by r times. Okay, I've already written this, right? Okay. So this is the form. And after this, to keep ak real, this imaginary part has to vanish, right? So we will segregate the imaginary part quickly. This will be 1 by r cos theta k. And if we take the I common, 2 minus of your sine theta k and into 1 by r. So basically this thing has to be 0. So if we like take the condition here, say if I take the screen a little upwards. So from this condition, sine theta k by r will be equal to 2, or sine theta k will be equal to 2r. First thing. So now there will be something tricky here. Finding out this condition is not alone, right? We have to check for feasibility and all. Okay. So guys, what is happening is, because sine theta k is getting equal to twice r, here what will happen is, for this condition, like if we want to place theta k in the octagon, like if we want to satisfy the different angles theta k for this equation into this equation, what will happen is this case is impossible. Why? Because it is impossible, right? Sine theta k for each of the internal angles can't be equal. This is impossible. There are 8 total angles and 8 total angles can't be same. Which means that, so this would actually mean that our assumption was a bit wrong. I intentionally did this because many of you would do this mistake while doing this with complex numbers. Okay. Many of you will assume, like, if you have heard, like, I don't know whether you hear me carefully or not. If you have heard me carefully, before starting this, I said I am assuming the circle at the origin of the complex plane. So this thing is entirely wrong, right? We don't know, like, this is a random octagon out of the blue. We don't know that either it will be centered at the origin or it will be centered at some other point. We are completely, like, not at all aware of that. So this was the place where we actually did wrong. Okay. So to correct this, what we need to do is, we will allow the circle to be centered at some random complex number. And after that, we have to do whatever we need to do. So basically, what I will do is, we will take a complex number z. This is not zk. Okay. This is new. This is z, which is equal to 1 by a minus 2i. And we will introduce a1, a2 afterwards. Don't worry about that. So the general equation for, like, general equation for a circle in the complex plane is mod z minus some complex number, say if we take it to be c, is equal to r radius. R is the radius, c is the complex number at which it is centered, and z is the general complex number. So mod z minus c is equal to r. So right now what I am doing is, I am putting this into this equation. Okay. So 1 by a minus 2i minus c equal to r within the mod, obviously. So if we little bit of do some calculation with this will be 1 minus c into a minus 2i mod is equal to r mod a minus 2i. Okay. Okay. Okay guys, wait. I actually figured out that we could do this a little bit more simply. Okay. Ignore this thing. What I'm doing is, just look at what I'm doing right now. I am taking this thing and writing what we did in the beginning. A minus 2i is equal to 1 by z. So a is basically 2i plus 1 by z. Okay. Now see. What I'm doing is, I'm again using the condition that a's imaginary part will be 0. Just like whatever we did above, all that discussion is same. And the same thing, imaginary part of a is 0. So basically, if imaginary part of your complex number a is 0, like, I should not say complex number. Imaginary part of a is 0, where a is real. Right? So it is not a complex number, obviously. My bad. So we can actually write from here that a will be equal to a conjugate. This is a condition that I hope everybody knows. So 2i plus 1 by z will be equal to 2i's conjugate is minus 2i, and this will be plus of 1 by z again. So if we try to simplify this a bit and take, okay, this is 1 by z conjugate, I'm sorry, yes. So if we simplify this, this will become 1 by z minus of 1 by z conjugate is equal to minus 4i. So in other words, if we simplify this, this will be z conjugate minus z by z conjugate is equal to minus 4i. Okay. So I guess this is not looking really good. Let's do one thing. Let's take z to be x plus iy like we always do. And therefore z conjugate will be x minus iy. So z minus of z conjugate will be what? Minus 2 times imaginary part of minus 2i times imaginary part of z. So this will be minus 2i times imaginary part of z, and the denominator is z conjugate, which means mod z square. I hope I don't have to explain these. And this is equal to minus 4i. So I guess minus I will get cancelled from both sides, and also 2 will get cancelled on this side. So you will finally have imaginary part of z by mod z square is equal to 2. Now let's do one final take and this question will be completely done. If we now put this z equal to x plus iy stuff into this equation, what we will get is y by x square plus y square is equal to 2. So y is equal to twice x square plus y square. Now guys, I hope you can understand what we will do right now. If you can't understand, that means you have not understood the question at all. Our target was to find out the equation of the circle which contains the vertices of the octagon. So right now what we will do is we will convert this into the circle's equation because everything is there, only we have to square it up. So 2x square plus 2y square minus y equals 0. So 2x square plus 2 times y square minus y by 2 is equal to 0. So I guess this will come out to be, wait, I am doing one thing. This will be just one step after, okay? So I am not doing that, I am directly writing the equation for you. This will come out to be x square plus of y minus of 1 by 4 whole square is equal to 1 by 16. So basically this is your required circle. And this is proof of the fact that we were wrong in the first place. Why? Because the center of this circle is 0 comma 1 by 4 and not 0 comma 0. Okay. Now this is a very huge mistake that everybody will make. So maybe I took 10 minutes extra in this question, but that is good because many people will do this mistake of taking the general, like, sorry, not general, they will take the specific equation of the circle in the complex plane, mod z equal to r. You are not supposed to take mod z equal to r in this particular case. Nobody has mentioned to you that the octagon is centered at the origin. You have to take mod z minus z1 equal to r, the general equation. Okay. Although what I did was I actually tried to avoid the general equation mod z minus z1 equal to r. I tried to avoid it, okay. But I will maybe, I can try to explain to you one thing which I guess you can relate, okay. Listen to me carefully, I am explaining. What happened is when we actually took this circle to be at the origin mod z equal to r, this thing, it was centered at your 0 comma 0, okay. I am telling you a language in English. This line, try to understand it, okay. Wait, I need to frame this somehow. Okay. Image of the real line under the transformation z is equal to 1 by a minus 2i is a circle of radius 1 by 4 centered at 0 comma 1 by 4. I am telling it once again. Image of the real line under the transformation z is equal to 1 by a minus 2i is a circle of radius 1 by 4 centered at 0 comma 1 by 4. Actually, the meaning of this is nothing very complex. I took the line z equal to 1 by a minus 2I as a reference line, and taking this as a, you can maybe take this as a minus 2 also, I guess, because I is equal to 1, 2, 3, 4, right? So take the least case, 1 by a minus 2 only. So if we take z equal to 1 by a minus 2 as a reference line, I took the image of the circle mod z equal to r at the origin in this reference line. Okay, basically the meaning of this is the circle we were considering previously is actually the image of this particular circle with reference, sorry, the image of the circle that we took before, which was wrong, the one centered at the origin, is actually the image of this particular circle with reference line as this particular line. Okay, I hope you can understand. These two circles are reflections of each other based on this particular line. Okay. Actually, explaining this to you would be a bit difficult because JEE Advanced hasn't bit of explored right now the image and all under complex numbers. Actually, they can any day. Okay. This is like, see, whatever you have under your conic sections, whatever, I can tell you one thing. Whatever you have under your conic sections, it is properties, it is some general point, it is whatever, whatnot. Okay. Everything you have under your conic sections in ellipse, parabola, hyperbola, straight line, circle, everything can be reflected into your complex numbers ditto. Okay, they can literally transform any problem into a complex number that you see in your conic sections in your books. Okay, they can easily transform it and they can give you in JEE Advanced, and you won't have any scope to say that this thing is outside my syllabus. So what I would say is, obviously you can't go on practicing questions like those because questions like that are not at all available. Okay, nobody will give you, and they are not at all available. Maybe I will try someday to make. So what I will suggest is, go on, like whenever you do complex number problems based on geometry, the question we did right now, this one, you should try to relate all the concepts you did in your like straight lines or conics, whatever. You should try to relate them in complex numbers. Like if I did this thing in my straight lines, I did like this. So if I reflect that in complex numbers, how am I going to interpret that? This should be your thinking. If this develops, then you can easily do, unless and until provided that your concepts in 2D, in conic sections and all, if they are clear, then only the understanding will help you reflect everything in complex numbers, and then the question, I guess, won't be a difficult one. That's the point. Okay, anyways guys, our like sum is not still completed. So this is the equation of the circle and radius of this is 1 by 4. Okay, now there's another twist, and twist is that you should know a formula which is very famous in properties of triangles. Once again, a very alarming mark. If you haven't done properties of triangles, I'm drawing an alarm mark also. If you haven't done your properties of triangles still now, today is, I am recording this video currently on 23rd of October. It's 12 in the midnight. So if you have not still done your properties of triangles, then please do. If you even don't want to practice sums, that I don't want to practice new sums and boggle my mind, don't do anything. Just like you would study your physical education before your boards, take up something like that. Maybe you can take up your theory books, Cengage or whatever you have. Just take up the formulas and just deep memorize them. Okay, just deep memorize them, that for this thing, this is the formula. Bus, you don't have to do anything else. Because, like, see, I am doing this sum. The area of a regular n-gon, okay, n-gon meaning n-sided polygon, inscribed in a circle of radius r. This has a formula which is half small n r square into sine 2 pi by n. This is the basic formula. Now, this particular formula, if you don't remember this, your sum is like completely doomed. It is completely doomed, right? Only remembering this formula, nothing else. You can see there is no concept involved here. It is just memorizing the formula, and wherever I'm needing it in the paper, I'm spitting it out. That's the only use. That's why I'm telling you guys, just memorize all the formulas. Okay, that will be enough. Afterwards, we can deal whatever will come in advance, because this is important for your mains. This question can come in your mains also. Please be aware. So here n is equal to 8, which means your 4 capital R square sine pi by 4, which is 4 capital R square times of 1 by root 2, and this is equal to 2 root 2 capital R square, and capital R obviously here it is 1 by 4, so 1 by 16, which means root 2 by 8. So this has come out to be root 2 by 8, and I guess they had told us to find out the value of 8 root 2 capital A. So 8 root 2 into root 2 by 8, which comes out to be 2. So guys, the final answer for this particular question will be 2. Okay, great question, a really good question. Like, I would say this is the best question I found in all the Allen papers I have been seeing since the past 1 month. So guys, I hope you are satisfied with this one. Now let's move on to the final question for today. Okay, so guys, here is the next question, and this will be the final question for today, but this is also a very fantastic question. Very fantastic question. I will not tell you right now what chapters this involves. I will hope that you all will try this out once if you are watching this video. So please try this out. I will wait for a few seconds and then I will explain what to do. Okay, so guys, this question is actually based on your complex numbers and binomial. Might seem a little absurd, but we have done questions like this before, okay? I have made you do questions like this in my videos also. I can remember we had done a question like this where I used Euler's form with trigonometry. I can perfectly remember, okay? So if you are watching my video since a long time, this should not be something new to you. Anyways, so guys, what we are going to do is I am taking theta r to be 2r plus 1 times pi by 400. So 200 theta r will be equal to what? 2r plus 1 times pi by 200, right? Okay, wait. This is 200. Okay, this is not 200 actually. This is 2. How could I make such a stupid mistake? Anyways, 200 theta r is 2r plus 1 pi by 2. And from there we can say one thing, that cos of 200 theta r will be obviously 0. Any multiple of pi by 2 when input into cosine is 0. There is no doubt to that. Okay, so guys, here actually is where enters your complex numbers. Now what I will do is I will take cos x plus I sin x power of your 200. There is a reason. I will explain why. So basically this is, I can write this as, I hope everyone knows, cos 200, cos x plus I sin x power of n can be written as cos nx plus I sin nx. So cos 200x plus I sin 200x. Very simply. First thing. So if I take out cos x power 200 from this bracket, I can write this thing as 1 plus of I tan x power 200. Okay. So this will be equal to what? Cos 200x plus I sin 200x. Okay. So now let's do one thing. What I will do is I am taking this cos x power 200 to the RHS. First thing. Second thing, now we will expand this. Okay. Just like we binomially expand, we will expand. So this will be 1 minus of your 200 c2 tan square x. Now there is like, I am not taking the imaginary values because once again we will need only the real values, not the imaginary values, because both parts are real, right? So why take in the imaginary parts? So odd terms will be basically the imaginary ones, so we will exclude them. So basically 1 minus, okay, not odd terms actually, like 200 ci. Wherever this I is odd, we will exclude all those terms. Okay. So 1 minus 200 c tan square x plus 200 c 4 tan power 4x and this will go on dot 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 till 200 c 200 tan power of 200x, and this is equal to cos 200x by cos power 200x. Okay. Okay, so first thing, let's identify for what this RHS of the equation will be 0. So very simply, I guess everybody can understand because we had already proved that here. It will be 0 for x equal to 2r plus 1 times pi by 400. Right. So if we like, and r is obviously your 0, 1, 2 up till 99. This is also to be noted. Okay. So guys, what is happening is, if I take this and say if I want to write this in some general form, say if I take a polynomial p of y, and then this p of y will be sigma m equals to 0 to 100 minus 1 power m 200 c2m and y power 2m. Please ignore this. This is y power 2m, and obviously here y is equal to tan square x. Now tan square x, I should say tan square xr, for r is equal to 0, 1, 2 up till 99, whatever. Okay, they are the roots of this equation. Now they had said that we want the sigma of this and the product of this. Sigma term was a and the product term was b. That is what they wanted from us in the question. So basically this is a monic polynomial, right? If I take y to be tan square xr, this particular expression is an expression for a monic polynomial. So the constant term will be the product of all the roots. So b becomes 1. Because 1 is the only constant term here, I can see at least. Okay, first thing. And second thing is, they have asked us to find out the sum of all the roots taken one at a time, not twice or more than that. All of these are taken one at a time. So for that, a will be nothing but coefficient of what? Y power 99. Okay. Okay, and guys, I'm sorry, I wrote this by mistake as y power 2m. This is y power m. Okay, the square is here. If we had taken it to be tan xr, then it would have become y power 2m, but it is y power m. Please correct that. So that is why actually we will take the coefficient of y power 99. So a is nothing but coefficient of y power 99. Now there is a twist. A will not be coefficient of y power 99 actually, because you know we take it to be minus b by a. In a quadratic expression ax square plus bx plus c, we always take it to be minus b by a, right? So this will be actually multiplied by a minus 1. Same thing, like whatever we do in polynomials, exactly same thing is happening. Okay, we have done these type of questions before and this has come in an Allen paper, so I will expect all of you to do this if maybe you had given this paper. So this is minus 1 power, actually it will come out to be minus 1 power 99 times of 200 c 198. Okay, don't confuse this minus 1 power 99 with this minus 1. This minus 1 is present explicitly only for the coefficient. Coefficient is this entire thing, outside this minus 1 is present. Okay, so minus and minus will actually become plus, and that is why a will come out to be 200 c 198, or rather 200 c 2. Okay, so guys, if you calculate 200 c2, I hope you can do it. I am writing the result. It will come out to be 19900, and b has come out to be 1. So AB will come out to be 1999999, not 19900, and we had to divide it by 25. So dividing this thing by 25, your final answer will come out to be as 796. Okay, these two were the most fantastic questions in this paper. Really good. This paper, the paper's level is overall not very high, I will say, but the paper's level in these specific questions has gone to extreme. I liked these questions. Really good. Anyways, guys, this will be the end for today's video. I guess the video has already become too long. So if you have liked my channel, do like, share and subscribe. Anything you want to say, you may come out in the comment section. And also do join my Telegram discussion chat for fruitful discussions on your JEE prep. And that's it for today, guys. Thanks for watching.